This sound will be heard by millions of people on a daily basis. This is going to be the future sound of the London urban bus. This was an opportunity to make a sound that was not only safe, but also beautiful. Something that would make the city a nicer, more pleasant and safer place to be. Something that would be a new icon for TfL, an audible roundel, a mind the gap, a unique branding, safety and creative exercise. We wanted to achieve something that felt totally familiar, but like nothing you've ever heard. An AVAS, acoustic vehicle alerting system. Electric buses are virtually silent when travelling below 20 kilometers per hour, and so need to make a sound for safety reasons. But Zelig were instructed by TfL to lead the sound design of the AVAS project in collaboration with Anderson Acoustics, who were advising from an environmental soundscape perspective, and AECOM, who were overseeing the regulatory requirements and providing measurement data. As soon as we were involved in the project, we saw the potential to impact the sound of the city for the better. No more cranking diesel explosions, no more rattles and vibrations, no more engine sounds associated with toxicity and pollution. And as an artist, the possibility of creating something that could affect our environment and people's lives for the better, and could also be described as a city-wide minimalist sound installation, was amazing. Along with Anderson Acoustics, we defined the brief: to create an AVAS London bus sound that is synonymous with TfL's brand position and values, whilst at the same time adhering to emerging safety regulations. It encapsulates London, our heritage, our future, our city. Using sonic mood boards and auditing the existing AVAS sound landscape, we explored and discovered possible directions and potential hurdles. The creation of the sound. We discovered we were naturally drawn to ones with these similar components: a low-frequency subtle rhythm or modulation, a subtle textural complementary pad, and a subtle modulating high-frequency component. All the sounds were played in acoustically modelled scenarios: a busy high street with multiple buses, a quiet residential street at a bus stop, and in a bus garage with multiple buses. All were presented in AECOM's simulation software and with calibrated headphones. We learned so much from these different stakeholder workshops, each time taking the verbal and written feedback of the participants and iterating on the sounds they heard and creating new ones. The standout bit of feedback was from the stakeholders with vision impairment. They voiced that they required a more rhythmic sound or impulse to help the sound stand out above the ambient sound of the city, and for localization. As soon as we heard this feedback and glimpsed an insight into how crucial the sound could be for people who rely on their hearing, we knew what we had to do. This is where the beacon part of the sound came from. We started testing various rhythms, adding to our existing popular sounds, and creating some additional sounds from scratch. We ended up with another 10 sounds that we then took into a final round of studio-based, more hands-on workshops. From here, the majority of the sounds were positively received, and we were excited to test them out in field trials in Tottenham Hale, London. In order to test the sounds on the bus, we had to tune or mix the sounds specifically for the proposed speaker being used, which had a very narrow frequency response, and also take into account that the sound subtly pitches up as the bus accelerates and lowers when it decelerates, at a rate of 0.6% per kilometre. It was at this point we decided to pitch the sound down by 2 semitones. By pitching the starting frequency down, you would hear the ideal version of the sound when the bus was travelling at its average speed. The field trials were really useful creatively, allowing us to hear the sounds on a moving bus and not just using the AVAS speaker in studio. This process, along with stakeholder feedback, helped us to modify, refine, and eventually land on our hero sound. It was these field trials that introduced the idea of having both a stationary and moving sound. Originally, participants at a distance were not 100% sure when the bus was stationary or moving. Splitting the sound into the stationary and moving or beacon layers solved this problem. This is the sound of the bus when it's stationary, and we add the beacon layer as soon as the bus moves. Lastly, we had to set the minimum and maximum playback levels of the sound and speaker in preparation for the EU Regulation 138 testing. And that's it. As far as the next steps go, we're looking into rolling out a new improved speaker so the sound reproduction is of the best possible quality. TfL are also exploring options to adjust the sound level output based on the bus location. For example, playing at a lower sound level in a quieter location and a higher level in a busier setting. The concept of creating a completely new engine noise outside the restraints of what a vehicle traditionally sounds like was a really interesting and nuanced challenge. We're looking forward to hearing the buses on streets and hopefully contributing to making the city a nicer and safer place to be.
My name is Paul Savage from BYD UK and I'm the operations manager. Behind me is one of two vehicles, self-surviving vehicles, that entered service in 2013 by BYD Auto into London. They were taken out of service in 2018. They were originally put in there for a trial to see how electric vehicles operated in London. I'd now like to show you around the vehicle and some of its components. This particular vehicle has three packs. Currently we're looking at pack 1 on my right, pack 2 is on my left, and pack 3 is on the roof. Each pack has 11 battery modules, lithium ion. These modules are monitored by these modules here, which in turn measure each battery module to make sure that the temperature of each cell is controlled in the way of temperature. This helps keep the battery charging continuous, that each cell is all charged and discharged at the same rate. Also here we have fire suppression if required, but it has never ever happened to date. So underneath this offside rear flap we house our two charging ports. These are the guns going to the charging ports and then the vehicle charges from the grid. This here is our 12 volt isolator for our 12 volt system. This here is our cooling radiator for our right hand side drive module and drive motor with a fan behind it. Here is the header tank for the Webasto heating. So in 2013 this vehicle didn't have electric heating. It was actually very, very hard because of the battery consumption. So this is where you top up the Webasto heating, which is currently located down here. Moving along, we have the fire suppression bottle, just in case there is a incident of a fire. Nobody likes them, but you know, they do happen, so this is a safety precaution. This is the bottle. This is powder, not fluid. Obviously we don't want fluid on high voltage components. Moving down to here, we have this air compressor. So the air compressor builds up air for the air brakes, etc. So that's the air compressor. We have the oil filter, because there's oil in this electric compressor, so oil filter. That component there is the air intake filter. Over the back, just down the back here, you might not be able to see it on the camera, but you may, is the high voltage power steering pump. So this is the power steering reservoir where the fluid goes, and this is the power steering pump to obviously aid the driver in steering the vehicle. Coming over to the right hand side now, this component here is the same as this component. So this is for the left hand side drive line, this is for the right hand side drive line. So again, this is a V2G, and this component basically allows the drive motor to drive, and also when you're charging it converts the three-phase AC into DC so the vehicle can charge. So moving on, this component here is our high voltage component, which supplies high voltage to our compressor and our power steering pump behind our air compressor. It also has the availability with these blanks here to supply high voltage to other components if required. This unit here is our DC to DC inverter, and what this does is it converts high voltage to low voltage to supply 24 volts into the vehicle.